number one complaint.
Sorry, can I get the women's questions?
The number one complaint from students and mathematicians about long division is right in its name. Long. Look at that question we just did. Mathematicians don't like writing a lot of stuff. There's a lot of stuff, and you were bringing things down and repeating. So mathematicians said, there must be a way we can do this faster and as a shortcut. And the answer is yes, there is. Something called synthetic division. It's a nice shortcut. What's the problem with most nice shortcuts? They don't always work. And they don't let you say, can you forget long division once I teach you the shortcut? No. There are some things that can only be done with long division. But there are certain cases where we can use a shortcut. So I'm going to show you the shortcut, and I'm not going to explain it. I'm just going to show you the shortcut, and I want you to see if you can come up with what did I do, and how does this shortcut work? And if you had a different question, could you do the shortcut? So this is how the shortcut looks. Start like this. I'm going to write the numbers 3, minus 1, 0, 3, and minus 20. And outside, I'm going to write minus 2. To help you with your shortcut, I'm going to even use colors. Bring down this 3. Then I'm going to write a minus 6 here and get minus 7. Then I'm going to write 14 here and get 14. Then I'm going to write negative 28 there and get negative 25. And finally, I'm going to write a 50 there and get 30. And then I'm going to go directly to my division statement and say P of x is equal to x plus 2 times by 3x squared minus 7x plus 14x squared plus 14x minus 25. And that seems a lot less work than what I did on the left-hand side. So the question is, can you see the shortcut? How did I decide to write these first numbers in black inside this box?
You ignored all the x's.
I ignored all the, as a mathematician, I don't want to write everything down. So I'll just write the numbers out in front. Sneaky. What about the number outside in black? Where did I get that minus 2?
You ignored the x and x plus 2, and then because you're subtracting for all the steps, you made it negative.
I made it negative. I could have made it positive, and then in each of the steps, I don't know if you noticed, in each of the steps, I added. In each of the long division, we subtracted. Where do you think students make more mental mistakes with adding or subtracting? Subtracting. So by changing the 2 to a minus 2, it allowed me to add instead of subtract. The first number I just brought down, that gave me the blue 3. How did I get the blue minus 6?
So you times negative 2.
I took the negative 2 times by 3. Isn't that what we did here? But every time we did it in long division, we wrote out the thing that we knew was going to be 0. As a mathematician, you're like, it's always going to be 0. Why should I waste my time writing that? I'm really concerned about what happens when I do the 3x cubed times the plus 2 and get the 6x cubed. And then I have to subtract. But now I'm adding. And then do you see, just repeat the process. Once you get the minus 7, how did I get the 14? Minus 2 times minus 7 gave me the 14. Then I added. And then the next purple 28, minus 2 times 14, gave me the negative 28. And then I added. And negative 2 times negative 25 gave me the plus 50, and then I add it. This will be your remainder. This will be your constant, your x squared, your x cubed. So two ways that you could write what I've underlined here in blue. By the way, this is apparently a 3 that didn't show up. 1, if you started with an x to the 4 and you pulled out an x, does that make sense? Your first term would need to be an x cubed, 1 less. That's one way that you can do it. Or you can work yourself backwards. I forgot that my remainder I still need in black. My plus 30 here as my division statement. The last number is your remainder, then your constant, then your x squared, then your x cubed. And so this is called synthetic division. And it is a shortcut. We can highlight it here in our notes. If I take out the highlighter. Synthetic division, and what do we do in synthetic division? We start by doing the opposite sign here. Write out the coefficients. Oops, there's one. Write out the coefficients there. Bring down the first number. Multiply and add. Multiply and add. The last number is your remainder, and finally you can write your division statement out.
Here's Megan's test.
Oh, thank you so much. Which lets us go to our last example. We can only do, though, synthetic division in a certain situation, and that certain situation is if you're dividing by x plus something or x minus something. If you're dividing by 2x plus something, right now we still have to do long division. Are there mathematicians that decided to create the shortcut for 2x plus something? Absolutely. You can look it up. If you're dividing by an x squared plus something, you still have to do long division. We're going to only use the shortcut if we're dividing by x plus something or x minus something. And we'll do our setup. And just like long division, the two important things are there. It has to be in the right order, and you have to include zeros when things are missing. So in this one, I'm going to double check. Is it in the right order? Yes. Is there anything missing? No. So I've got both of those things are fine. I don't have to add any zeros on this one, and everything's already in the right order. But can you see on the exam they like to check those things? Because if you're not paying attention for a second, that could be a very easy mistake to make. And what number am I going to put outside here if I'm divided by x plus 2?
Minus 2.
A minus 2. I don't even change colors anymore on this one. I just go to a different color. Bring down the 3, you would get minus 3. Minus 3 times minus 2, plus 6, add 8. Minus 2 times 8, minus 16, add negative 13. Plus 26, add 22. Negative 44, add negative 39. I'm going to put this in brackets, and above it say let p of x equal, so I don't have to rewrite all of that. And then my division statement, p of x is equal to, I divided by x plus 2. And I started with an x to the 4, so this means I should get an x cubed plus 8x squared minus 13x is plus 22. And there's a remainder of 39. This is my d cubed plus remainder. And you can circle 8, 9, 11, and 12.